4 charred seeds were enough to rewrite the history of smoking. They were found inside a 12,300-year-old hearth in the Utah desert. No pipe survived beside them, no pouch of dried leaves, no carved image of a person inhaling smoke. Just 4 seeds from a wild tobacco plant, trapped in ash older than agriculture. They prove that hunter-gatherers were deliberately handling tobacco thousands of years earlier than archaeologists once believed. But they leave behind a more unsettling question. What exactly were those people doing with it? They may have chewed the leaves. They may have carried the plant for medicine. They may have thrown it into the fire and breathed what rose from it. Archaeology can preserve a seed, but it rarely preserves a decision. That means the first act of smoking may be hidden not because it never happened, but because the action left almost nothing behind. The real origin of smoking was probably not the invention of a pipe. It was the discovery of a repeatable effect. At some point, a human group burned a plant and noticed that the smoke changed something. Perhaps it sharpened attention. Perhaps it reduced pain. Perhaps it caused dizziness, calm, visions, or fear. The important moment came later, when someone remembered the effect and recreated it deliberately. That required memory, comparison, and the ability to connect an invisible reaction with a change inside the body. This is why ancient fire matters, but not in the obvious way. Evidence from Wonderwork Cave in South Africa shows that members of the human lineage were using fire deep inside a cave roughly 1 million years ago. For hundreds of thousands of years, human ancestors were exposed to smoke from different woods, resins, grasses, roots, fungi, and animal materials. Most smoke was unpleasant. Some drove insects away. Some preserved food or changed its taste. A small number of plants may have produced effects strange enough to be remembered. The first smokers did not need a theory of chemistry. They needed only one observation. This plant does not feel like the others. That observation could spread through a group without writing. A child could watch an older person place a certain leaf on hot stone. A healer could remember which smoke eased pain. A ritual specialist could guard the location of a rare plant. Knowledge could survive as a gesture, a smell, a season, or a rule. Do not burn this one alone. Use this one at funerals. Inhale only once. Keep children outside. Collect it from the high valley, not the riverbank. The most revealing evidence appears when archaeology catches both the object and the chemistry. In northern Alabama, researchers tested residue inside a carved stone smoking tube around 3,500 years old. They found nicotine, directly connecting the device to tobacco. But they also detected tropine, a compound associated with plants such as datura. That detail suggests the bowl may not have contained a single plant. Ancient smokers may have been creating mixtures designed for different effects. That turns a pipe into something more sophisticated than a primitive cigarette. It becomes a controlled delivery system. A pipe changes airflow. It can cool smoke, concentrate it, slow the burn, and separate the user from the heat. The shape of the bowl influences how plant material burns. The length of the tube changes how the smoke feels. A mixture can be adjusted by memory, more of one plant for stimulation, less of another to avoid sickness, a resin to keep the ember alive, a leaf chosen because it altered dreams. None of this required laboratory measurement. It required generations of dangerous trial and error. Many plants that affect the nervous system have a narrow distance between a noticeable dose and a harmful one. A group that survived long enough to build a tradition had probably also learned which combinations caused panic, vomiting, unconsciousness, or death. The successful ritual was therefore not just the discovery of a powerful plant. It was the discovery of limits. Tobacco was unusually effective because nicotine produces a fast and repeatable signal. It interacts with receptors used by the nervous system for attention, arousal, movement, and reward. Modern brain imaging shows that even 1 or 2 puffs can occupy a large share of nicotine-sensitive receptors in a dependent smoker. The effect arrived quickly enough for the brain to connect the plant, the fire, the hand movement, the smell, and the social setting with what happened next. That speed changes behavior. Humans are especially good at learning from immediate consequences. A plant eaten at noon may cause sickness after sunset, making the cause uncertain. Smoke inhaled now can produce an effect within moments. The brain receives a clean lesson, repeat this action, and the state returns. That is one reason inhalation could become such a powerful human technology. It shortened the distance between experiment and result. But chemistry alone does not explain why smoking became ritualized. The object itself can become part of the effect. The hand reaches for the pipe. The group becomes quiet. A specific smell appears. Smoke becomes visible. Breathing changes. Everyone expects something to happen. Long before the active compound reaches its peak, the brain is already responding to the pattern. Modern addiction research shows that cues can trigger craving before the drug arrives. The sight of smoke, the familiar hand movement, the sound of a lighter, or the presence of other smokers can activate learned expectation. Ancient rituals almost certainly used the same learning system, even when the people involved understood it through spirits, ancestors, medicine, or sacred power. The body did not need the correct explanation. It only needed repetition. This may be why smoke became attached to moments that societies wanted people to remember. On the Pamir Plateau in western China, archaeologists found wooden braziers inside a cemetery roughly 2,500 years old. Heated stones had been placed inside them, and chemical residue revealed cannabis compounds associated with psychoactive use. The outside surfaces did not show the same pattern, which means the plant was not simply growing nearby or blowing into the graves. It had been burned inside the vessels. The method was unlike modern smoking. There was no need for each person to hold a pipe. Hot stones turned the enclosed space itself into the device. Cannabis placed on those stones would produce smoke that filled a tent, chamber, or ritual area. Everyone inside could breathe the same air and enter the same altered environment. The chemistry revealed another hidden clue. The residues were more consistent with cannabis selected for stronger psychoactive effects than with ordinary fiber plants. The people may not have cultivated modern high C varieties, but they could identify naturally potent plants from particular high altitude regions. A society does not need a percentage label to know that one valley produces stronger effects than another. It needs memory, comparison, and trade. This means ancient intoxicant use may have shaped movement and exchange. Rare plants could travel with merchants, healers, migrants, or ritual specialists. A plant gathered in one ecological zone might appear hundreds of kilometers away because its effect had social value. The trade was not only in food, stone, or metal. It may also have been in altered states. A Greek account from roughly the same broad era describes Scythians placing hemp on red-hot stones beneath, felt coverings, and reacting loudly to the fumes. For centuries, that scene sounded like the kind of story outsiders tell about unfamiliar people. But heated stones, braziers, and cannabis residue now make the basic method archaeologically believable. The written account and the chemical evidence point toward the same design. Enclosed air, selected plant, heated stone, collective inhalation. The collective part may have mattered as much as the drug. A funerary smoke ritual could combine grief, darkness, firelight, chanting, rhythm, synchronized breathing, and expectation. Each factor can change attention and memory. When several people experience an altered state together, the event becomes evidence that the group shares something outsiders do not. The smoke becomes a boundary. Those inside have crossed it, those outside have not. That can strengthen identity. Modern experiments show that synchronized movement can increase cooperation and feelings of connection. Ancient ceremonies may have amplified this through breath and intoxication. A group entering the same smoke-filled space could interpret bodily changes as contact with ancestors, proof of loyalty. initiation into adulthood, or confirmation that a healer possessed special knowledge. The plant changed perception, but the ritual told people what the change meant. This is one reason ancient smoking cannot be reduced to recreation. In many settings, it was a social instrument. Smoke could authorize a decision, it could mark an agreement, it could separate ordinary time from ceremonial time. It could make pain feel meaningful. It could turn private grief into a shared experience. It could also give specialists power, because the person who controlled the plant controlled access to the state it produced. That power may explain why knowledge about certain plants was restricted. A dangerous mixture could not be handed to everyone without rules. A ritual specialist who knew the dose, preparation, timing, and antidotes possessed information that looked supernatural to others. The smoke was visible, but the mechanism was hidden. The person who understood the sequence could appear to command an invisible force. Medicinal smoking grew from the same principle. Inhalation acts quickly. Classical Ayurvedic traditions described dhumapana, a controlled practice of inhaling smoke from prepared herbal substances. The instructions could specify ingredients, timing, how the smoke entered, and how it should be exhaled. This was not random exposure around a fire. It was a protocol. The reasoning was more advanced than it first appears. The lungs provide a rapid route for certain compounds to enter the body. Modern medicine still uses inhaled delivery because it can act faster than swallowing a substance. Ancient practitioners had identified the route correctly, even though they could not measure the toxic particles created by combustion. The hidden innovation was not simply burn a plant. It was dose management. A person could take one inhalation, wait, observe the effect, and stop. The strength could be changed by adding less material, increasing distance from the heat, altering airflow, or mixing the active plant with weaker material. Smoke made the dose difficult to measure precisely, but easier to adjust moment by moment than many swallowed preparations. This flexibility helped smoking appear independently in different regions. The plants changed, the devices changed, and the explanations changed, but the human problem was the same. How do you make a plant act quickly, predictably, and in a way that can be shared or controlled? There was probably no single birthplace of smoking. In the Americas, tobacco became central to pipe traditions. In Central Asia, cannabis was burned in braziers. Elsewhere, people inhaled aromatic, medicinal, or psychoactive smoke from local plants. Once a community discovered that heated plant material could change the body or mind, it had the foundation for an inhalation culture. The most important contrast with modern smoking is not that ancient people were wiser or safer. Many ancient practices were dangerous. The difference is that use was often limited by